This is another example of calculating the enthalpy changes. This time it's reactions that involve a solution. This could be a solid and a solution, or it could be two solutions together. So again, I use the equation MC delta T. I have 0.5 grams of magnesium being added to 25 centimetre cubed of 1 molar HCl. Temperature increase from 21 degrees to 27 degrees. So again, this is an exothermic reaction. Mass 25. I do not include the mass of my solid because the heat generated from this reaction is being used to heat up this solution. It is not being used to heat up the metal. So 25 grams of solution, because I also take the assumption that my hydrochloric acid solution is the same density of water. I also assume it has the same specific heat capacity, so 4.2. Times by change in temperature, you can see that's 6 degrees. 25 times 4.2 times by 6 is 630. Remembering that that is in joules, so I divide it by 1,000 to get it into kilojoules. But enthalpy changes, remember, are per mole. Now for this reaction, I have to work out which of my reactants is in excess and which of my reactants is limiting. So start with an equation. Magnesium plus hydrochloric acid, making magnesium chloride and hydrogen, make sure it's balanced. Okay, work out the number of moles of each, 0.5 grams. So 0.50 divided by 24 0.5 divided by 24 is 0.0208 for magnesium. For my hydrochloric acid, the number of moles is equal to the volume times by the concentration divided by 1,000. .025 moles. Now, you may look at these numbers and think that the hydrochloric acid is in excess because that has the greatest number of moles. However, we need to take into consideration the molar ratios. So if all the magnesium was to react 0.0208, you would have to times the number of moles of magnesium by 2 to get the number of moles of hydrochloric acid that reacts with. 0.0416 moles of HCl would be needed. Do I have that number of HCl? No. So my HCl is limiting, magnesium is in excess. Not all the magnesium is going to react because there is not enough acid for it to react with. Therefore, when I'm working out my enthalpy change for my reaction, so delta H equals, I use the number of moles of my acid because this is the limiting reagent. So 0.630, that's my change in energy, divided by 0.025. Remembering this is an exothermic reaction, so minus 25.2 kilojoules per mole.